So just up at the top, equation of midline. So I wrote it down as d equals, really is y equals, and when we're talking about it's also the midline is d equals, right? So kind of the equation of the midline should be y equals. The midline itself is d equals, okay, or the d value itself, right? So if you want to find d, you use this. The equation of the midline, which is actually the line itself, right? If we're going to actually draw that line in. So when we were graphing, if we said, well, let's graph y equals 14, this is what you're graphing, right? Y equals. So to get the midline itself, the equation of the midline should be y equals, and the midline itself is d equals. And one other thing, if the equation is given in this form, and they do this at some points in the book, so if they take the b and put it in front of the brackets, then in this case, the start point will be negative c comma d. Okay, so the start point. If it's written in this form, y equals a sine b bracket x plus c plus d, then the start point is negative c comma d. Okay? Now the only time you need to worry about this is when you're doing some of the questions in the book if they ask you, and they may talk about it as a horizontal shift. Okay? So if they ask you about the phase shift or the horizontal shift, if it's given in this form, it's negative c O comma d, that's where the start point is. If it's in this form, then it's what we said yesterday, negative c over b comma d. Okay, as far as the diploma goes, you don't have to worry about either of them, right? You're worried more about the values of a, b, and d. Okay, so just wanted to clear that up, because you will see questions written in this form, and so you should know that that's what goes with that as far as start point, right? So just, keep that handy. Otherwise, okay. Oh, and now she is. So the test center was full yesterday.
Yeah.
When did you write?
After school today.
Perfect. You might just have to get there early.
Come after school.
After school today? Okay.
They're just so full.
I know, because you and thousands of kids like you. Given the equation of a sinusoidal function, what can we tell if we just get the equation, right? And this equation is usually going to be in the form and we write that form because tomorrow when we do regressions, that's the form your calculator gives it to you, right? So if we run a sine regression and we get the equation, we want to know, well, what can we say about the equation? So today is the what can we say about the equation, tomorrow is let's practice doing some regressions, and then what can we say about the equation, and its graph and all of that, right? So in other words, just looking at the various characteristics of the things. So let's start off with an equation. Y equals, pick a number, any number. 6. 6. Sine, pick a number, any number. 5. Good, somebody could think of a number. Pick a number, any number. 4. Actually, no, I'm going to make that minus. Minus 4. And pick a number, any number. 2. Plus or minus? Plus. Okay, so here is a randomly chosen sine equation, right? I know nothing about this. And what we want to do is we want to describe everything we can about this just from the equation itself, right? Without having to graph it. And then we'll graph it and we'll see if the graph matches what we think we know from what we have here, right? So I say midline, you say 2. So maybe here we're going to write down, what's A? What's A in this equation? 6. What's B? 5. What's C? And what's D? 2. Okay? So in a sense, that's kind of obvious, right? But this will be on your formula sheet, right? I mean, they give you the formula. Y equals A times sine bx plus c plus d, right? They give you that formula in that form. So that's the form that Alberta Ed is expecting stuff to come in, right? Which is why that other one where I said, well, if they put the b in front, that's pretty much specific to the book and those few questions where they're asking stuff about it. Okay, so the midline we know is 2, right? It's y equals 2. That's the equation of the midline. So let's hear it. We'll say equation of. The equation of the midline is y equals 2. You know, the midline is 2, which is the d value. Amplitude, what's the amplitude? 6. So, here, let me ask you this. What's the maximum value? 8. How do you get 8? Yeah, so from the midline, which is 2, we know the amplitude is the distance from the midline to the maximum, right? So the maximum is going to be d midline plus a amplitude, which is 6 plus 2, which is 8. So we have a maximum value of 8. What's the minimum? -4. How do you get that?
The midline minus
Yeah, so we go to the midline again, which is at 2, but this time we go down 6. Right? So we have d minus a, which is, no, I wrote those in the wrong order. So d plus a is 2 plus 6, which is 8, and d minus a is 2 minus 6, which is -4. What's the period? Or what's the formula for period? Okay, so the formula you're going to be given on the formula sheet is the period is 2 pi over b. So in this case, in this particular case, what's the period? 2 pi over 5. All right, so a sine function has all of these defining points. Right? It's got a midline, an amplitude, that leads to a maximum and a minimum. We've got a period, and the last thing we have is the start point. So what's the start point? So there's the formula for it. Right? And if I want you to have any additional info, I'll put that on the test, right? So I might write in start point. Matter of fact, I might put all the formulas for sinusoidal just on the top of the sheet instead of handing, you know, because the formula sheet only has 2 of them on there. So what do we get?
Oh, I just have a question.
No.
I thought you said when we're given the equation in that form, it's -c, not -c over b. Why is it?
No, it's -c over b, comma d.
It's always that?
Yeah.
Okay.
Now, those of you that understand transformations, you know, you'll look, if you look at it, then you'll say that's moving right, because you know that, right? But we don't do transformations in 30-2, so to remove that, so in a 30-1 class when we're looking at it, we would never even say start point, right? We would just say it's a horizontal translation by this much. So really, it's a horizontal translation, right, c over b units. Okay, I'm going to take care of that by putting that negative there. Okay, so I do that because of this course, right? Because we don't really study transformations in this course, so I'm not going to, you know, there's no point in either teaching transformations and using the language. Okay, so what's the start point? Oops. Whoops. Cut that out. I want an eraser. Okay, so we've described everything that there is to describe about this particular function, right? we know that so here's what I would do. If I were given this information, right, given all this information, I would start with, what do I start with? Come on, start with a new page. So what do we have? Y equals 6 sine, what was B? What was the equation? 5 plus 2. Okay. So if I was given that, and I wanted to say, okay, so what is this graph going to look like? Draw myself a little graph. I would start with the midline. Right, so I would write down d is equal to 2, right? Or y equals 2 is the equation of the midline. And then I would say, okay, from there, my maximum is going to be at 8, right? 2 plus 6. And my minimum is going to be at -4. So I would label, right? I draw in the midline, and then I would take the amplitude and go up that much and say, okay, I got a max at 8. And I would take the amplitude and go down that much and say I got a minimum at -4. So I know that it lies in between those two. Its period is, what do we say, 2 pi over 5. That's weird. You guys picked a bad number. You should pick 2 or something, right? No, it doesn't really matter, right? Period is 2 pi over 5. And its start point is, what do we say? It was 4/5, comma 2, right? So we're going to start here at 4/5, comma 2. Right? That's our start point, so 4/5. And then we're going to draw. Now, we don't have to draw this, right? We already have all the information that we could possibly glean from this. We know what the max is. We know what the min is. You know, think about it. If this was the equation of a Ferris wheel, we would know the maximum height. We would know the minimum height. We would know the radius of the wheel. We would know how long it takes, right? The period would be how long it takes for one cycle. And really, what else do you need to know? Okay? So if I am going to graph this, then let's just go to here, and let's just graph this here. Okay, what was the equation? Y equals 6 sine. What was B again? 5x minus 4 plus 2. Okay, plus 2. Okay, so let's move this down a bit, and let's change our scale, right? I mean, because we're showing away too much there. So let's say we go from, I don't know, -1 to maybe 5, right? Yeah, we can see lots there. And what do we say? The minimum was -4. So let's go -5, and the maximum was how much? 8. So let's say 10. All right, I think that's pretty good, right? And we got to be in radians though, right? So remember, most of the time you're in radian mode. Any graphing you're doing, pretty much in radian mode, okay? All right, so what have we got? Oh, let's draw in, while we're at it, I always like to see the midline, right? So y equals 2. Kind of lets me know I got it right? Because now I can see, yeah, okay, that is in the middle, right? So 2 plus 6 is 8, right? We got a maximum of 8. 2 minus 6 is -4. We go down to -4. So we know our minimum and our maximum. Our start point. Well, that's not our start point, right? Because what's the characteristic of the start point? It's got to be going up. 0.8. 4/5, 0.8. Right? So there's our start point at 0.82. Our period. So I can measure period from anywhere. So let's say I do the period from there to here. So it's 2.057 minus 0.8. Let's get a calculator. Let's get out of that. 2.057 minus 0.8. So 1.257, but what did we say our period was? 2 pi divided by, what do you think it's going to say? Pretty close, right? I mean, really, actually, because these aren't exact. If those were exact, then it would be exact, right? But I mean, the 3 decimal places, that's close enough for us, right? So there you go. From the equation alone, we have found out all the information that there is on the graph, right? We know where it starts. We know what its amplitude is. We know what its midline is. We know what the maximum and the minimum are. And what else? It starts. We know what its period is. We have all the info. So let's go to the real world. In the real world, the number of hours of daylight in Montreal is given by So some of you may find yourselves living in Montreal at some point. You'll have this equation in your math notes, which you threw out years ago. Right. But no, we know that number of hours of daylight wherever you are is going to be sinusoidal, right? We know that in December we don't have much daylight. And we know that in July we have a lot of daylight. And in between we get more and more. So now as you're waking up in the morning, you say, hey, it's daylight out, right? Now we also went to daylight savings time. That kind of messes stuff up a little bit. But it doesn't change the number of hours of daylight, right? That's not changed by the time at which the sun rises or sets. We know we're getting more and more daylight now, right? When we get to spring, oh, we're past spring, aren't we? So in March then it should have been about equal, right? 12 hours of daylight, 12 hours of night. Now we get more. When we get to summer, which is what? March, April, May, June, which is June 20th thereabouts, then should have the maximum hours of daylight. After that, days will get shorter, right? Until we get to the shortest day, well, until we get to fall, which is when they're equal again, and then we get to December 20th, winter, which is the shortest day, right? Shortest number of hours of daylight. And so the number of hours of daylight is given by this equation. Say H of T. We gotta write this right, right? There we go. Here's the equation. So where d of t is the number of hours of daylight and t is the number of days after January 1st. So t, number of days after January 1st, days after, and d of t, number of hours of daylight. All right, so we got this equation. Let's figure out what A, B, C, and D are. So, what's A? 3.6. What's B? Jumping ahead a letter. What's B? Yeah, 2 pi over 365. So B is what you're going to find after the word sign, but before the letter X in this case, right? Now, this is written a little differently, right? This is written in the form, well, it's actually, so 2 pi over 365. What's C? $80. And what's D? 12. So really, this is written in the form, that's kind of D plus A sine B X plus C. Right, so the D comes out first. And sometimes you'll see it written that way, right? You just have to write, D is the constant that gets added, right? A is what's in front of the word sign. In this case, our C, so our shift in this case is not negative C over B, it's C, just negative C. Okay, oh, sorry, that should be negative 80, right? Negative 80. So in this case, our shift is written as, our shift is just negative c, not negative c over b, because the b's already divided out, right? That's written this way. All right, what can we say about the number of hours of daylight? So now we have a specific situation. So each of A, B, C, and D means something. So what is the median? We'll say what is the median. What does it mean? So in this context, what is the median? What does it mean? I'm going to tell you. No. So the median is in the middle, right? It's in the middle. And what are we measuring here? Daylight. So this is the middle number of hours of daylight, right? So it's the average hours of daylight in Montreal. So the median is the middle. That's why I use median instead of midline, right? Median, meaning the middle. So what does it mean? It's the there are, on average, 12 hours of daylight. 12. In Montreal, right? So the average number of hours of daylight is 12. What's the minimum number of hours of daylight? Minimum hours of daylight is minimum 8.4. So how do you get that? Yeah, so 12 is in the middle, right? And the minimum is, so 12 is D. The minimum is D minus A. Subtract the amplitude, right? From the middle we go amplitude down and we go amplitude up. So what's the maximum, Michaela? 15.6. Okay, so minimum daylight is 12 minus 3.6, which is 8.4. The maximum daylight, is 12 plus 3.6. Okay, so we have D minus A to get the minimum, right? From the middle minus the amplitude. We've got D plus A to get the maximum. What else is left? So we got the median. So we've dealt with D, we've dealt with A, we've done everything we can with them, right? We've interpreted what D means. The A just means there's a swing of 3.6 hours of daylight, you know, above or below the median. So we got B. So what's the period? Well, period is 2 pi over B, which is 2 pi over 365, which is 2 pi times 365 over 2 pi, right? Because if I'm going to divide by a fraction, I have to multiply by the reciprocal, which is equal to, and you won't be surprised if I said the period was 365, because what does that mean? 365 days in a year, right? And number of hours of daylight is going to repeat on a yearly cycle, right? Temperatures will repeat on a yearly cycle. So a lot of stuff that's measured in nature, right? Number of hours of daylight, time of sunrise, time of sunsets, those are all going to repeat on a yearly cycle. average daily temperatures. So it doesn't mean we can predict the specific temperature on a day, but we can have an average. We know that on average on April 8th, the temperature is this, right? And you'll see the forecaster, and they'll be showing you below average or above average. Okay, so if you wanted to predict, you'd say, well, let's hope that it's the average temperature. But and then what else do we have? We've got the start point, which in this case will be 80 and 12, right? So if I graph this, right, and you can graph this on your graphing calculator, which I'm not going to do. Let's change that to 12. And let's put this in. So it's 12 plus a sine 2 pi divided by 365 bracket x minus 80. Okay, I think that's pretty much it, right? Now, we're not going to see much because we know that stuff goes from 8.4 to 12, right? So we need to set a window. And our x values, we're doing a year, so let's go from 0 to 365. So 0, 365. And our y values, we can go 0 to, what was 15? Let's go 0 to 20. And then we can get rid of that stuff. And it's kind of nice showing us the intercepts, right? Or it's not really the intercept. This is, let's change that one. Let's go instead of 0. So we said minimum of 8.4. Did we? Yeah. So so let's say 8 to 16. There we go. 12. Okay, something's wrong. I do not have the right equation. I need a 3.6 here. 3.6. Oops. Hide that. That's better. Wasn't going down quite. It was a little too flat, right? Because I left the A value as 1, so it was giving an amplitude of 1. So here's your start point, right? What does that mean? It's when you first reach the average number of hours of daylight. 80 days will be around March 20th, right? It's 31 days and then 29 gives you 60 days in January, February, and then 20 days in. So March 20th, which is the beginning of spring, which is when we first hit that average, right? So at 80 days, we hit. Until then, we're below, right? So we're further below down here. So in January, we're starting to climb. We hit the average number of hours of daylight. We peak at something off the screen there. We peak at, can I move the whole thing? So around day 171.3, if we figured that out, it would be around June 20th, around the middle of the year, right? And we come back at day 262.5, which if we figured it out would be fall, right? Which would be in September, right? Around September 20th or thereabouts. And we have a minimum value, which is going to hit down here somewhere, 8.4. 353 days, so about 12 days shy of the end of the year, around the 19th, 20th, right? So there's all of our seasons, right? Minimum number of hours of daylight at winter. The median hours of daylight will be at spring and at fall, and the maximum hours of daylight will be at summer, right? 15.6. Let's just kind of move that back. Yes.
How's the start point beginning if it's supposed to be negative C over?
Oh, you missed the beginning of class. Sorry. If it's I explain if it's written in another form, there's a slightly different form the book uses, and in this case the b value is pulled out, and so it just is the c value. Okay, any questions on that? All right, so you can see that given the equation and a context, right? I mean, there's a context to this equation. What is this? Number of hours of daylight. Given an equation and a context, we can tell a lot about what's going on, right? The average number of hours of daylight is 12. It varies 3.6 from that, right? So from 8.4 to 15.6. The period is 365. The shift is 80, okay, to the right. So 80 days to the right, which is the start of that. All right, let's go to another page. And let's do another. Okay, so one more. I think 2. Two more. The number of people employed in the resort town of Jasper. Can be modeled by the function y equals where x is the number of the month where January is month 1 and y is the number of people employed in thousands. Okay, so the number of thousands of people employed, just so you don't think there's 5 people employed in Jasper on average. All right, so let's do an analysis of this. On average, how many people are employed in Jasper? 5,000. Yeah, it's in thousands, right? Not 5. Okay, so on average, there are 5,000 people. So that's the D value, right? D is the median or the average, the middle number. What are the fewest number of people employed? Say during the year. From, so what's the fewest? From 3,400. And what's the mostest? 6,600. So during the year, from 3,400 to 6,600 people are employed. Okay, so we took the median, which was the average number of people employed. We took the amplitude to find the minimum, 5 minus 1.6, which is 3.4, but it's thousands, so 3,400. 5 plus 1.6, which is 66, 6.6 or 6,600. What's the, let's do, what can we do? Yeah, let's ask a couple questions. How many, what's the period here? Just out of curiosity, I'm just curious about the period. It doesn't, so period. Period is equal to 2 pi over b, which is 2 pi over 5, which is 2 pi times 5 over pi, which is 10. Which seems a little weird, because what was X is the month number. There's not 10 months in a year, so. And that should probably be pi over 6. So you know what? We're going to change this. Pi over 6. Pi over 6. Pi over 6. That'll give us 12. I mean, it can't be seasonal. It can't be seasonal and then keep changing, right? Like every 10 months. It should be seasonal through the year, right? When would we expect the most people to be? What months would you expect the most people? Winter? Okay, when else? Summer. Winter and summer, right? I mean, they're heavy. You know, people travel up there in the summer, they go up there to go skiing or whatever in the winter. And we would expect fewer people probably in the spring or the fall, right, during the change of seasons. Using this equation, let's determine the number of people. So determine the number of people employed in August. So what do we have to do to determine the number of people employed in August? What do we got to do to figure out August? Yeah, change x to 8, right? August is the 8th month, so we'll make x equal to 8. What mode is your calculator in? Or what mode does your calculator have to be in? Radians, right? So you got to be in radian mode to do this. Okay, and what will we get? Check mode, yep. .57, 8. So what are we going to say? So 3,578 people are employed in August. So things are starting to go downhill in August. And the other thing we can ask is, during which month are, how many people do are, so when are 6,597 people employed? So how are we going to solve this one? we're going to have to graph this, right? The only way we could solve, in this case, we're given y, right? We're given the number of people. We want to know x. So it's 1.6 sine pi divided by 6 x plus 1 plus 5. And what do I graph for y2 to get 6,597? 6.597, right? Because remember, the numbers are in thousands of people, so 6.597 thousand people. We need a window for this then, right? So we'll say, well, it's months, so let's go 0 to 12 months by 1. And we know the min and the max, right? It's 3,400 to 6,600. So we can go 3,000 to 7,000. So, sorry, but it's in thousands, so we can go from 3 to 7 by, whatever, 0.5. Hit graph, and we should get a graph that fits the window, right? Which this very nicely does, right? It's very nicely in there. And it looks like pretty much we're just hitting the peak there, you know, and then otherwise it's out of the year, so it looks like it's just one place. So second, calc, intersect. Actually, you know what, I'm going to extend my window up so I can see a little bit higher. So let's go to 8. Because I don't want the line. So it may actually cut in 2 places. So second, calc, intersect. Actually, no, let's go up here. It's easier to trace along a straight line than along the curve. 1, 2, 3. So 0.9, what month is that? January, right? During month 1. Looks like it might also, let's second count, intersect. Looks like it also might be just over here a bit. 1.2. So it's around January. It's around the end of January, really, right? It's around the end of January then is when, so we'll say around the end of January. End of January, beginning of February. All right, so the 0.9 puts us in January, 1.2 puts us into February, right? Partway in. If you want to figure out what day that was, you just multiply by 365, right? No, you do not multiply by 365. You multiply by, I don't know what you do to get what day that is. It's months. I don't think you can convert it to days that easily. Never mind. Last one. Ferris wheel. So height of a chair and a Ferris wheel is represented by y equals 5.2 sine 0.29x plus 8.1, where x is the time in seconds. And y is the height in meters. So before we ask the specific question that could be asked on a test, let's run through everything that we should know about this or could know about it, right? And they're not going to ask you all of this, right? On a test, you're just going to be asked something like, at what time is the chair at a height of 12 meters or something, right? But from this, what do we know? What's the 8.1 represent? Sorry?
Midline?
The midline, okay, and on the Ferris wheel it is the axle or the hub, right? So we know the hub of the Ferris wheel is at 8.1 meters in the middle. What's the 5.2 represent? Yeah, on the Ferris wheel, what does it represent? 5.2, what's that? The radius, right? It's the radius of the wheel. What's the maximum height? You should be able to do that without a calculator. As they reach for it. It's 13.3. What's the minimum height? It's too hard to do without a calculator. It's 2.9, thank you, yes. She did that without a calculator, folks. 2.9. So we know that it goes from 2.9 meters to 13.3 meters. Why is it 2.9 meters? Why isn't it 0? We don't load at the ground level, right? We load on a platform, and that platform. So the loading platform is like 2.9 meters in the air. Okay? I mean, you could set one up where you load below ground. If you had a permanent thing, you could set it up where it loads at ground level, right? Because you could dig it down in. But what else do we have? What's period? This you need a calculator for. So what's the period? I'm not writing anything down, so you gotta listen. What's period? Really? How long does it take? Wait, could have got rid of that. 21.6 seconds, 21.7 seconds, right? It's in seconds, right? So A and D are measured in meters, right? A is the height of the hub, A is the radius of the wheel in meters. D is the height of the hub in meters. B is measured in x-axis units, right? It affects the x-axis, which in this case is seconds. But B isn't, it's not like 0.29 seconds, right? But 2 pi divided by B is the period, which is 21.67 seconds, right? So that's how long it takes to go around. It's not a huge wheel, right? It's only 13 meters high. I mean, the school's probably higher than that, so. Or as high as that. But here, the question you're actually going to be asked is, when is a chair at a height of 12 meters? So how do we solve this?
That was the Y1, isn't that the 12 into Y2 and the intersection?
Exactly. Okay, so we go to y equals, let's clear out what we got. Clear, clear. I want the 12 in y2 because I want to know that height. I'm going to put 5.2 sine 0.29x plus 8.1. Window. Okay, so we know that a period is 22 seconds, right? So we can go from 0 to, I don't know, 25, let's say. And we'll go from 0, and the maximum was 13.3, so let's go to 15, say, by ones. Okay, graph. So there's a cycle and a bit, right? Because it kind of starts not quite at the middle, right? But, you know, this one cycle would go from here to about here. So we don't need to worry about this part over here, right? We have two numbers that we're going to find. Now, another question that could have been asked is, for what duration is the height of the Ferris wheel above 12 meters, right? Then you got to find the two times and take the difference between them. So that's an alternate version. Okay. In this, we're just going to go second calc, intersect. I'm going to go up to the straight line because it's faster to go along the straight line. And go 1, 2, 3. So at a time of 2.9, rounding to the nearest tenth, you know, we need some rounding. So 2.9 seconds and 7.9. Okay, so what times? It's at 12 meters at a time of 2.9 seconds and at a time of 7.9 seconds. And it's at above 12 meters, at or above 12 meters for a duration of 5 seconds. Okay, so during your ride, you'll be up here at or above 12 meters for a total of 5 seconds. All right, that should do it. So just to be aware, let's back up. For those of you that were a titch late, the equation of the midline is really y equals max plus min, but the d value is the same thing, right? So really the equation of the midline could also be written as y is equal to d, right? You figure out d, and then y equals d is the equation of that actual line. And if something's written in this form where the b value isn't right next to the x, where it's separated, so the x, or in this case we saw t minus 80, that was in brackets like that, then the start point will be at negative c comma d, not negative c over b comma d. Okay, so if you just go back to this page, make the changes. If you were late, somebody near you should have those changes made on that page already. Right, so again, equation of midline, that's the actual line you draw, y equals. And the midline itself, the d value is that. And if it's written in this form, so in other words, if you don't see anything in front of the x in the brackets, see here it's bracket bx plus c, so there's a number in front of the x inside the brackets. Here, the x or the t, the variable, is by itself in the brackets with the c value. So for those of you that have done transformations, you'll recognize this is the form we would want, right? We need to get x by itself, and then we just say it goes, you know, left c units or whatever. And in this case, to get x by itself, we divide it out, and that's why it's negative c over b. The negative to flip the direction, and the c over b to take the b out. Right, so that's it. So you can do the 8.4 stuff. I believe it's 8.4. Okay, remember they do some stuff in degrees. We really won't be asked a lot of degree stuff. You're going to be asked more